So in the previous tutorial videos, we have gone over all the basics for doing object-oriented programming, constructors, attributes, mutative methods, and also accessor methods, and also how you use the dot notation. So those concepts are all necessary for you to complete the lab exercises and also for the coming lab test. I would like to take this opportunity to really make a very short video, the current one, to really go over with you the kind of formats that's going to be consistent for the next 2 lab exercises and also for your coming lab test, which will all be on OOP. Okay, so now this will be something you'll be given. I'll talk about what you will be given and what you'll be expected to do. Let me talk about it very clearly. Okay, so what you will be given will be some Java file, which will be I already created a package over here. So for this particular class, you do not have to type it out. Okay, I just want to give you the idea. You can do the exercise where you are given the exercise for the lab 5 or lab 6 later. Okay, for this particular, of course, for version 1.1 and version number 2, you still have to make sure you type them out in order to get your credits for the lab 5. Okay, now for this one here, this will be one example Java class you will be given. So you basically are given only a single class, which does not compile to begin with. Okay, it does not. Okay, unlike lab test 1 and lab test 2, you're always given something that compiles to begin with. But for lab test 3 and also for the coming labs, you will be given something that does not compile to begin with for doing OOP. And then you will be given some kind of tester, in this case point tester. And then you'll be given a main method which can be executed as Java application, and then you will be given lines of code like this, and then some lines over there you can see system and out print line over here, and also system and out print line. Between the system and out print line, you may use the new expression to create new objects, and also you may try to call some accessor method so you can store the return value into some variables, or you may call some mutative method to modify the attributes for the context object, right? We talk about all these concepts in the previous video. So now what I would like to show you is exactly what you will be given and what you will be expected to do. I'll do that for this particular simple example together with you. You follow the same pattern and the workflow for completing your lab exercises and also for the upcoming lab test. Okay, let me explain to you very quickly. What you will be given will be 3 things. You will be given, number 1, you will be given some English description of the problem. For example, like the one we went through for the points, right? The points being 2-dimensional plane, and also x and y coordinates, you can move any arbitrary directions, and also the distance between any points, right? That's what we talk about. You will be given some English description just to give you some intuition, okay? And most importantly, you will be given a point tester class or some kind of tester class with a main method, inside which you will be given lines of code which would not compile to begin with, simply because there are missing classes or missing methods that you have to create in order to make everything compile. And also when you execute the final classes you create as Java application, when you try to create it and try to execute point tester again as Java application, you're going to get the given expected output. Okay, let me just show you the workflow very quickly. So you will be given some problem description in English. You will be given a tester with a main method which refer to maybe some class which doesn't even exist, that you are not given such classes. Okay, and then you will be given some expected output, which means once you filled in all the missing classes and methods and re-execute the point tester, in this case as Java application, you will get exactly this output over here as expected. Okay, if you can get that, that means you're done. Okay, so now let me mention to you exactly how you can do it. Okay, now, so your task over here is to create all the missing classes. Okay, one more stringent requirements you want to have for the classes that you create. Classes and also methods you create must not contain any system.out.println statements. Okay, that's a very important criterion you want to do. You want to stick to. You only have system.out.println statements inside the main method. That's the only place you can have system.out.println, which is already given to you. For all the methods you create outside this class, you must not have any system.out.println methods. If you see any, you're gonna receive very low marks. Okay, let me show. Let me go back here. Okay, so now I want you to. I don't want you to get confused. In the previous version 1 and version 2, we start from creating the classes from scratch. But now, given that you know how to solve this particular point problem, I want to give you some exercise in the reverse way. This will be the format for your labs and also for your lab test. So let's say we have a new package over here called example problem. And the problem itself will contain the point tester over here. That's exactly what I just point to you over here. That's one of the given inputs to you. And also assuming that you also have some problem description for you, and also we got this expected output over here. Eventually, when we execute it, so currently we just cannot execute this particular point tester as Java application because we got red cross over here, which means you got some compile time errors. You want to fix it by adding the classes and also adding the methods. Okay, so now I want to give you some guidance on how to get things work. Okay, so now let me just point to you several places that you want to really pay attention to. Okay, number one, whenever you see any assignments over here, for example, this is one single assignment, this is another assignment. On the left hand side of the assignments, we are trying to declare a variable. For example, over here, the variable type is simply points, and the variable type over here is simply points. When you have red underline over the type of the variable, that simply means the class does not exist. In this case, your response should be immediately create a class by yourself. Okay, so let's do that quickly. So now what we can do is you can go back to the Package Explorer over here. So under example problem, I'm just going to say new, and then I'll say class. Okay, because I'm expecting a point class, right? So I'm going to put point class right away. So now, without any main method, right? Only the tester has the main method. And then when you say finish, you can see that we just created a new class over here under the example problem. If you go by the point tester over here, you can see what used to be underlined over here has gone, which means because we have already created a class, right? That's the only missing class for us. But now we have new problems over here. Basically, you see a new red underline over here, which means the constructor over here has not been defined. If you move your mouse over, it simply say the constructor points with double and double is undefined, which means you want to create exactly this kind of constructor, which will take double and double. And also you got another constructor over here, which will take character and double. That's something you want to define as well. So basically, not only that we have to create a point class, we also have to define the two constructors in the point class. Let's do that very quickly. And over here, I can simply say points for the constructor over here. So now what should be the type for the constructor? If you move your mouse over, it should be double and double. Okay, it's going to be a double okay. So it's going to be a double and then maybe X, double, and then Y. So that's a minimum you can do. Of course, you may have to fill in still some other code as well, but that's the minimum. Okay, let's go back here and you can see over here we simply got the new points over here, the constructor, and also the second kind over here, which will take a character. Okay, so now we should put in the character as well. Okay, so now we'll say points and then char, maybe some C, and then double, and then X, for example. We just want to make the compiler happy. So now if you go back there, so now you can see we have defined the two constructors over here, one version for the other. Basically, the tester will give you hints about what should be created. That's why the tester would not really compile until you have filled in all the details. Okay, so now let's go a little bit further. You can see we have, as we said before, we have a method call over here. The context object is simply just P1, and P1 was declared to be of type points. That means we're missing a method in the get description. And the return value for get description can be stored into a string. So that tells you it should be an accessor method that returns a string. Okay, let me say that again. Okay, if you look at that, if we see that this particular line over here doesn't compile, what we should do is, first of all, you want to look to see if there's an accessor or mutator. You can see there's an accessor because when you try to make this particular method call, it can be stored into a particular variable that tells you it's an accessor. So this should be the return type of the accessor, and this is a context object which was declared to be of type points. So that means we want to add in this particular method into the point class, and now it takes no input arguments, right? It takes no input values. That's exactly what we're going to do. So we go back there, and then we go back to the points, and then we just need to define another accessor method in order to make sure this line will actually compile. Okay, let's go back there, and then we'll say string over here get. You're gonna type verbatim, get description, and then you can see that it takes no input over here. Okay, because you can see there's a accessor method, as we said before, you must return something. Okay, to make it just compile, you can just declare some local variable to be result, to be initially empty string, as I said before, and then return the result, just to get things at least to compile. Okay, you can see everything in the point class also compiles, right? You got this new method added in. That's exactly the flow you want to go through for the labs as a practice, and also for the lab test where we eventually assess you. Okay, you can see everything in the tester compiles except for P1 and P2 over here, right? You can see P1 again is a context object that's declared to be type points. And this is actually not an accessor because it doesn't return anything to be stored. Okay, so what you can see over here is, when I look at this line, you can see for this particular method here, first of all, the context object is P1, which is of type points. So we have to define this particular move method in the point class, which will take so this is a character literal, so that should be a char, and also 3.4, it cannot be an integer, it must be a double, right? So this must be a double as well. Okay, so now what we do is we go back there. So that means this guy here has to be a mutator. And this method over here must be an accessor. So when you go back there, we'll simply go back to the point class over here and then try. Okay, we can go to void, and then that would be the mutator syntax, and then move. You gotta spell verbatim. Okay, if you go to the point tester here, it has to be spelled exactly like that. And then we need to give one character and one double. Okay, so it can be one character C and also one double and then D, for example. Okay, the parameter name can be renamed a little bit later. And now that's the minimum you have to do in order to make everything compile. So now what's happening now is, from the initial point tester we gave to you that didn't compile, by adding just the minimum, by adding one class called points, by adding the two versions of constructors, by adding the accessor, and also by adding the mutator, everything that you have to add is hinted by this particular tester we gave to you that didn't compile. Now everything compile. If I try to run point tester over here to say run as point tester as Java application, I'm simply going to get something like this. You would say P1 is something, P2 is something. You can see simply just empty string, because you can see initially get description will simply return an empty string, which is just minimum. But now if you compare this particular output that's actually produced by your program right now, compare with the expected output, it's simply not right, because you can say P1 is expected to be 3.2 and minus 4.8. P2 is supposed to be 0.0 and 8.3. And after calling the mutator method, they should change, right? So getting things to compile by adding classes and methods is only the step number one. Step number two, you really want to make sure you fill in the body of the methods for the constructors over here and also for the methods over here in order to make everything work. For example, let me do it very quickly. Okay, for this one over here, it might just be, I can say, also, in order to make it work, I have to say about the attributes, right? There's something, you can define more attributes than what's required, and also more method than what's required. So now I can add in more. I can say double x, double y. Okay, over here, I can say this dot x is assigned to x, exactly what we said in the previous tutorial video. Now y is assigned to y. And also I can say if c is equal to the x-axis, in that case I'm going to assign this dot y is assigned to 0, and this dot x is assigned to, now I can maybe rename this a little bit. Rather than x, I can say maybe distance. Okay, Okay, otherwise, if it is y, in that case, I'll say this dot y is assigned to 0, this dot, sorry, that'll be this dot x will be 0, and this dot y is simply assigned to the distance. Okay, so you can check the solution in the previous two versions that I talked about in the previous video. And get description, I can simply say result is assigned to, for example, parenthesis plus this dot x plus comma plus this dot y plus over here and the closing parenthesis. Okay, finally, how do we move? You can move either up, right, left, or down, right? So now I can say if we're going to move, let's say up. In that case, we're going to say this dot y is assigned to this dot y plus the distance. Else if see if the direction is, let's say, down. In that case, we're going to say this dot y is assigned to this dot y minus the distance. Okay. Else if the direction is, let's say, left. In that case, this dot x is assigned to this dot x. That's exactly what you have to do. Minus d. Okay, finally, we know that the else part will be as if we say that it's going to be right. This dot x is assigned to this dot plus the d. Okay, so now you can see that exactly. So step number 1 is to get a minimum of the methods, constructor, and etc. to get things just to compile. And step number 2, you may have to fill in some attributes in order to implement your methods, right? And then you're going to fill in the body of the constructor for the two versions, also fill in the body for the accessor, and fill in the body for the mutator, so that eventually when you see the expected output, it's going to be the same. Okay, so now if I go back here, if I right click and run as Java application, so now if you look at that, this particular output that's produced by my program is exactly the same right now as the expected output. Initially it wasn't, right? But now after some coding, so you're going to get an expected output. This is how we're going to assess your object-oriented programming skills. Okay, let me recap very quickly, and then you can practice by doing this week's and next week's lab. Okay, the idea is like this. Let me just summarize very quickly. So what you're given is over here. First of all, it's going to be a problem description, which will be describing English. And number 2, you have given some tester which does not compile in the beginning. Okay, not compiling over here. And also number 3, you will be given the expected output. Okay, so these are the 3 things you will be given. So what's the tasks for you? You want to make sure eventually you want to make the tester not only compile, but also when you execute the tester as Java application, it's going to give you the expected output. Okay, what you will do is, number 1, you want to add in missing classes. And then for each class you add, you want to add in methods. Adding missing methods as well. And here, when I say methods, it can be either constructor, it can be accessor, or it can be mutator. So once you have added them in to the minimum level, it's going to make sure this can compile. However, even if it compiles, when you try to execute the original tester as Java application, it may not produce what's being expected. So what you have to do is, you may want to add in maybe extra attributes. Maybe you want to also add in, let me use a different color to tell you it's really important. You may also want to add in attributes and also implements the methods properly. Such that eventually when you try to execute a tester, that is not only going to compile, but when you execute it as a Java application, it's going to match exactly the expected output. Okay, that's kind of the expectation and the workflow for you to complete the lab exercises and later on for the labs. So you're always given something that will give you hints about what you should really create. Your task, number one, also another thing to mention, never change the tester. Never change the given tester. Because that one there tells you exactly what you have to implement. You don't want to change the requirements over there, okay? You only add in the methods and attributes as you see necessary in order to achieve the expected output eventually, okay? So that's something I would like you to go over very carefully before you try to complete the lab exercises.